Welcome everyone to our August episode of CPD in 43. We have Peter Wilson from Mass Timber Academy speaking to us today, all things timber. What I'll do is I'll hand it straight over to Peter, but as usual, if you could ask any questions within the chat box. You should be able to see a question already posted as a poll within the chat box. If you could all have a look at that and answer that, that'd be much appreciated. If you have any queries and questions, please do ask, and I will then field those during the Q&A session towards the end of the talk, and then I will also highlight the events for the remainder of the year. If everyone could have a look at that poll, hopefully everyone can see it. Can everyone see it? Okay, I'm just going to repost the poll. Just give me a second, but I will hand it over to Peter nonetheless, and disappear off into the back.
Good afternoon, everyone. My name is Peter Wilson. I'm director and founder of the Mass Timber Academy, and I'll explain more about that in a moment. But thank you all for attending. I'm delighted to have been invited by CIAT Wessex to do this presentation. We've been developing courses for other CIAT regions, and this is an introduction really to the whole world of mass timber. What is it, why you need to know about it, what you need to know, and how knowing some of this will hopefully have benefits from a career perspective and for your businesses. So I'll press on, presuming that everyone can hear and see me. If not, I'm sure I'll be interrupted. So the Mass Timber Academy, what is it? It's really about providing you knowledge and education, if you like, to understand more about the systems that are available. And this is a kind of introduction, if you like. I've put in a few shots of interesting buildings that have been done in recent years, and I'll explain more about some of those shortly. So that's me. I've been involved with things to do with the world of solid laminate timber systems for the best part of a quarter of a century. You can see that thing, leaflet there, it says laminated wood. That was a conference I ran in probably 1998, I think, or 99. And it was kind of, I suppose, prescient in saying laminated wood material for the next century. Subsequent to that, working at Edinburgh Napier University, running a research centre, I ran a lot of conferences about the developing world of mass timber. And you can see one from, I think, 2009. There was, I think, one of the first conferences in the UK about cross-laminated timber, and a book I wrote recently is at the end there, and I'll come back to that later. So what is the Mass Timber Academy? We established this 4 years ago, and really it came out of a lot of inquiries I was getting for over many years from architects and engineers and technologists asking about what are these things, why can't we get them made from UK grown timber?
Hi, Peter, just a quick one. Should you be sharing your screen?
I am. I thought it was. Okay.
No, it's not up. But whilst I'm on, we've had over 100 responses to that question, and it's 80-20, 80% not having used mass timber technology in their career and 20% having used it.
Right. Well, there we are. Okay. Has the screen come up?
Yes. If you just, we're on what is the Mass Timber Academy slide.
Excellent. Right. Okay. Well, I'm sorry, everyone. I thought I pressed all the right buttons there. We've had quite a lot of technical problems, so I won't bore you with that. But at my end of things, not at CIAT Wessex end of things. But yes, we established this 4 years ago, and it really came out of a lot of questions from technologists and architects and others about the different technologies. We recently ran a 6-part course for 2 regions here in the UK of CIAT, just to explain far more about what these different things were, where the technology was going, and what people needed to know. So hopefully a little bit of that in this very short session, we can explain some of that to you. So, oops, I've just pressed the wrong button. There we are. So why are we doing this? Partly it's because, at a very simplest level, almost all schools of architecture and technical colleges and departments of engineering still don't teach anything about timber, never mind mass timber systems. So we decided that gap needed to be filled, and filled quickly, because a lot of work is going on in the UK, people specifying, designing buildings with using different mass timber products and systems, but not necessarily knowing enough about them, and certainly a lot of the contractors not knowing enough about them. So that previous slide was really to say the world is changing. Most of the population is shifting to cities, but climate change, we're seeing all this in the last few weeks, the incredible changes going on. We need to look at how we can respond to that sustainably and sensibly as professionals in the construction sector. And this whole question of the 1.5 degree issue is fundamental to construction, because so much of the world's greenhouse gases are generated by the construction industry internationally, and we really need to think about how we need to change and what that change requires. So, and when we say change, I've listed 2 columns there: the energy crisis, climate emergency, Brexit, post-COVID, cost of living crisis. We all know those things. We hear about them. What we do about them is another issue. On the other side, on the right-hand side, you'll see things that are very particular to the construction industry in this country. We have problems with damp in buildings, condensation, poor or no thermal insulation, poor air tightness. We also have poor construction quality, and that's been exacerbated by the loss of skills, either people retiring from the industry brought on by COVID, or people leaving the industry brought on by Brexit. But we also have a lot of inappropriate materials and products being used. We import, for example, more than 80% of our construction timber into the UK. This is not sensible in the modern world. And when we look at Mark Farmer's, something's happening. Oh, my buttons are going too fast here. Look at Mark Farmer's prediction. He wrote a very, very good report, a seminal report in 2016, saying there were 10 years to save the UK construction industry. 5 years later, he wrote another shorter report saying nothing much has changed. And that's partly because our industry doesn't change unless it's forced to by regulatory means or legislation, whatever. And we need to really get serious about this. So I'm not trying to be harbinger of doom here, really to say there are huge opportunities and possibilities in what I'm going to talk about. And partly that's to do with what I showed with that global picture. The urban densification process is rapidly increasing movement of populations, not just from country to city, but from country to country, as we see, and there's lots of debate about in this country. The climate emergency, we know about net zero carbon targets. We're nowhere close to meeting the circular economy. There's some energy towards developing that, is not yet at the level it needs to be. The use of renewable materials is still a kind of early stage for a lot of practitioners, and the use of, even thinking about the use of homegrown timber resource. And I'll come on to that, because we have an issue here in this country, which is we don't actually manufacture anything. Most of the things we produce as mass timber systems, CLT, etc., we import. It was possible to manufacture, and I'll come on to that later, but we need to think much more about the resources we have here, and particularly the renewable resources we have here. So is mass timber the answer? Well, it's up to you, really. We can either all be in the vanguard of change, or we can lag in the slipstream. We can look at all the research, the projects going on elsewhere in the world, and still feel, as many contractors I speak to do, they say, "Ooh, this is a new product. This is something different. This is risky. We need to put a premium on the price here." That's not really the case, because and I'll say that in a moment, because when you look at the massive growth in the mass timber, and this is just a slide about laminated timber, CLT, you can see the growth that's anticipated even over the next few years is massive. It's international. It's an international career opportunity as well. So it's well worth examining and looking at, saying the European CLT industry is huge. There's more than, well, probably more than 40 companies. I think it's about 30 I put in this slide. And it's quite extraordinary. We're probably the one country in Europe that isn't producing this product. There's a lot of interest in it here. There's been a lot of buildings, probably more than 1,500 buildings in the UK have been built with CLT, or CLT as a component in a hybrid system, but we still don't produce it. So This is the building, I would say, was the first CLT building. So we've actually been using CLT in the UK for nearly a quarter of a century. This, when the roof and the walls here of the Shrewsbury Music School, Pringles Richard Charter, or PRS as they're now known, did this building. And it was a very early thing. They discovered something about CLT. They went to a company in Germany, Dick Holtz, and brought CLT panels here and introduced them into this building. So we've actually been at this for quite a long time, and yet we still find in the Mass Timber Academy lots of questions saying, what are these new products? How do we use them? And now I'm not saying that critically of people. There's been a lack of information, a lack of education, and we really need to catch up. So there are many properties and benefits in the use of, and I'm saying mass timber as a collective term here because I'll come on to what the different mass timber systems are. But you can see here there are lots of benefits that come from the use of CLT or glulam and so on. And actually, I probably have a list of about 50. I think there's about 20 here, or maybe less than that, but no more than I'm limited in the number of slides I can show you today in terms of time. So, okay, what do we actually mean by mass timber? Well, you can see here two in green, non-glued systems, nail laminated timber and dowel laminated timber. I suspect that most people I'm talking to here today don't know much about either of those things because we don't use them or make them here. The glued systems, I think probably most people, I suspect, will have come across glulam in some shape or form, perhaps even for small things like lintels, perhaps for bigger things, roof beams and so on. A lot of technological development has gone into glulam in the last few years to see some extraordinary things through parametric design and related manufacturing, which was never possible before. Cross-laminated timber, you've probably all heard of, judging by the poll, not used, but I suspect by listening to this presentation, you're interested. So you'd like to use these things, but you'd like to know more. LVL is even less well known. It's probably the coming thing because it's the most efficient use of wood from a tree that we've got, and very, very high strength and stiffness properties and remarkable opportunities in terms of being able to shape and twist in two directions. So that's just a very brief introduction to those. Nail laminated timber, you can see from this illustration, it does what it says in the tin. It started in North America, nailing in the 19th century, nailing big planks of wood together to create flooring systems in warehouses. We have a whole presentation about just nail lamination, so it's not just a pass you by kind of thing. This is an example of one in China, which, okay, the main panels are developed by a company in Vancouver, Structurecraft. And and you can see on the roof the way the panels are being connected to each other manually, but the main panels are prefabricated. And so it's not just a rectilinear opportunity of just simple box sections of nailed panels. We can do all kinds of things, and that's increasingly the case. Dowel lamination. Yes, it's a non-glued solid timber, laminated timber panels. You can see here, just like nail lamination, a pile of boards, this time with holes drilled through, so you're not nailing from board to board to board. You're drilling holes all the way through a stack and then inserting hardwood dowels into softwood boards. And the difference in moisture content between the hardwood and the softwood reaches equilibrium moisture content. The hardwood dowels expand, lock the whole thing together. And that's basically the technology. But there are actually 5 different types of dowel lamination, and we do, again, the whole course in this about all the different types and the different opportunities and the reasons why this is an interesting technology. And partly it's an interesting technology because this is something we could manufacture locally throughout the UK. We don't need a huge facility with humidity and temperature control for the curing of glues. We can do things more local to the forest and so on. So this is an interesting thing and worth coming back to. This is an example of one made with homegrown timber, Welsh timber, down in Wales that architects did. So you can see it's not a building lacking in quality because you're just using unglued boards. It's actually a very high quality project, but we don't have many dowel laminated timber buildings in the UK, possibly a handful. Off the top of my head, I can think of 5, but this is something we could be doing a lot more of. and using our locally grown timber, whether the species that are available in the south of England or in Scotland or in Wales, different opportunities are possible. So if we move on to glulam, we get it now in all kinds of shapes and forms: straight, curved, double curved, interlocking, freeform. It's a world away from simple post and beam components, which we're probably all familiar with. This building, this house extension in London, is built, occupies pretty much the whole back garden. You can see the roof light there, lets light through glass in the floor, through several levels of basement. It's a very remarkable building because every piece of glulam there is individually tailored to fit. There's no identical pieces there, and every piece was brought through the house to build this in the back. So it's all things are possible, but through the kind of computer technology we have to design things, but also the computer technology we have to manufacture things. And we can get new structural spatial solutions with glulam. This is using very basic beams, but overlapping, crossing, everything else to get a remarkable quality of interior in this convent in Norway. Then if we move on to cross-laminated timber, I've said here, it's very definitely not a fashion item. It's treated in the magazines kind of like that. Oh, well, we're all using this now. It's all the latest thing. And it's partly the latest thing because it locks up massive amounts of atmospheric carbon dioxide over a long period of building and possibly beyond if we reuse the materials. It's a very sustainable way of building. It's a very quick way. In that list I showed earlier, it's lightweight buildings. So less foundations, in this particular example in London, beside a canal, less foundations. And in London, you're over Victorian sewers, underground train lines. We need to think differently just about pouring lots of concrete into the ground. It's not the way forward. It's still necessary in many instances, and I'll talk about hybrid structures possibly if there's time, but the same way, the point here is that prefabrication of panels and beams and so on means fast assembly, very precise connections, maybe within 1 and 2 millimeters, and quiet on site. That's a big thing in urban situations, being able to build quietly with few tools and no waste, because all the waste, if you like, is not just produced in the factory, it's reused there for firing kilns and so on to dry timber. So hardwood CLT is something we have made in the UK, and this project here in the courtyard of the V&A in London was done by was designed by Wachters and architects and Arabs. It's hardwood. It's a tulip wood from East Coast USA. It grows like a weed there, but it's generally used there just for furniture or plywood manufacturing. But it's a beautiful material, and its great benefit is it's incredibly strong and stiff and lightweight. So we brought timber from America to Scotland. We graded the timber. It was the lowest grade of tulip wood, but American Hardwood Council wanted to show that it had other properties when put into mass timber components. So we sawed it into boards, we finger jointed, we planed it, and then it was sent down to huge CNC machines in York to manufacture into 120. Well, the panels themselves were made in Glasgow, but the boxes were made in York and then shipped down to London to be assembled here without foundations, because that courtyard floor is over a gallery. And it was a kind of three-dimensional maze, but it was about showing we could make modular buildings, but also showing we could actually make CLT in the UK, albeit this is imported timber. Then on the fifth of the systems I'm talking about here, laminated veneer lumber. This building is in Seville in the south of Spain. It covers several city blocks. It's an enormous building interlocking laminated veneer lumber. And if you don't know what laminated veneer lumber is, I should have explained this when I showed that diagram of 5 systems, because LVL is what it says. It's a veneer. So what happens is that logs, instead of being cut up in sawmill into boards, it's actually the logs themselves are rolled against the blade. So there's a continuous rolling thing, creating a continuous sheet. So the log is reduced down to about the size of a broomstick diameter. And that continuous sheet is cut into different sizes. They're overlaid, glued to build up very large panels, or just simply standard size boards, similar to the size of a plywood board. But when you get into much bigger lens where you can cut and shape and twist and so on, you begin to see the possibilities for different kinds of building forms, perhaps building forms that relate more to building types, new building types, and the large, ever larger building types that we're seeing, and needing to find ways of building them that are not being built with concrete or steel for large spans. And I say that not because I've got an axe to grind against concrete or steel, but because these are extractive industries that are non-renewable, and we need to think much more about. And the thing about wood is we can grow more, and really in the world, or the world that we live in, wood is that the most available renewable resource we have. In other parts of the world, a lot of research is going into bamboo and producing some extraordinary buildings and materials or products from that. I'm not going to talk about bamboo here because, well, basically it's grass, not wood. And that's nothing, I've nothing against bamboo. I think some of the things that are going on in the world at the moment are just remarkable. But here we see, I showed you there was softwood LVL, and most of these products are all made from softwood. Whether it's dowel lamination, nail lamination, glue lam, CLT, LVL, they're generally made from softwoods because they grow straight, they grow fast. The ones that they're made from generally from disease-free trees. But in the last few years, we've seen the emergence of hardwood LVL, and this is an extraordinary product because it's very strong, it's very stiff. It means that for the same structural section, or same structural strength, if you like, and stiffness, you can have a smaller section than you would do with a softwood LVL beam or post or whatever. And this project is remarkable insofar as this is built in the City of London, and where, well, really since the Great Fire of 1666, the London Building Acts kind of outlawed timber in construction, and we see most things ever since made in other ways. The world is changing, as I've said at the beginning of this presentation, and what you see here is a building that went up very fast, very precisely, incredibly quietly, and is completely of wood. Not just the structural frame, which is LVL, is CLT panels, which are that floored the whole building. The core for the stair and lifts is timber, and the cladding as well is thermally modified tulip wood. So this is an interesting building, not just because of the technology, but because it's a commercial building in London made from timber and in a very dense area of London. And so part of that is, and of course, with all these things, all these products conform to various UK and European standards for adhesives, structural design, EPDs and so on, CE marking. And we're still using all these things because, strangely enough, in the government's recent decision not to kind of change to some UK version of European product declarations and so on, construction products weren't included in this. So we still, inevitably, because we're importing so many things, the way and the standards we're looking for all the time are to do with what's available in terms of European standards. And then, okay, the elephant in the room. We know that after the Grenfell fire, a certain amount of reactive legislation was brought in England and Wales. It was to say anything over 18 metres, the entire thickness of the wall had to be non-combustible, which, if you've worked on timber structures, platform timber frame or anything, you'll know this is quite difficult in terms of all the layers that we put into walls nowadays for all kinds of things. But the structural thickness of the wall is a problem. In Scotland, it was less of a problem because we've been used to building with timber frame for many years, and so the legislation was introduced here only applied to the cladding, which was the issue, of course, with Grenfell, because there was no timber in the whole of Grenfell in terms of its structure or external cladding. The cladding was a problem, but we know these things. But the legislation proved very reactive to the opportunity of what was then the fast-growing market in particularly London to build up to 10 stories of residential accommodation. Now, that's an important distinction because obviously for insurers, risk managers, warranty providers, there's actually a number of different issues. They look at what the difference between low and medium rise buildings, between high rise and complex buildings. They look at distinct structural systems, whether it's lightweight timber or mass timber. They look at risk groups. Is it in the construction, or is there risk for the developer? Is there risk for the end user? So there's a lot of different insurance issues, which now there's a lot of work going on to sort out. These are some of the recent reports in the UK just examining this. I saw just yesterday that Aviva have said, look, they're much more open now. They've looked at all of this. They're much more open to mass timber buildings, well, commercial buildings, I should say. And that's an important distinction because, strangely enough, with the legislation that was introduced in England and Wales for the building regulations, the legislation applies to residential structures over 18 metres. So there's been talk about reducing that to 11 metres, but legislation doesn't apply to commercial buildings. So buildings are still being designed in London in mass timber construction, in timber. They're not restricted in terms of height or wall thickness or anything else. And that's an interesting distinction. I think just in the rush to produce legislation after the Grenfell tragedy, it was focused all on residential structures, and quite rightly. But there's still other possibilities. And I think a lot of the research that's gone on recently into fire issues is a major issue for insurers. But the other major issue for insurers is moisture, moisture in penetration, and that's a whole other world in itself. And we have courses on that and on the fire side of things to talk about what you need to know to control moisture ingress into mass timber, because it doesn't perform the same way as a concrete slab or a masonry building. It's quite different, and timber will always perform differently. So I'll move on more positively, because those other things are things that we talk about in our courses, and try to give you all the information you require to be able to think and look about, think about design, think about specification, think about what kind of contractors you want to work with, and to other consultants who can all buy in to the idea of building with mass timber. So we ran a conference some years ago about the vertical timber city, talking about the increase around the world since the Stadthaus in Murray Grove in Hackney was built as 9 stories. It was then the tallest mass timber building, or tallest timber building around, and that produced an extraordinary amount of interest from engineers, particularly around the world, who began to look at timber in a completely different way, or at least some engineers, not because engineers are not trained in timber construction. It's the ones who really saw opportunity in this who have been driving the agenda, to the point where this building in Skellefteå in the north of Sweden is 20-story timber hotel. There's a town hall, there's a library, there's a theatre. This forms the whole core of the town here. All of the timber for this building came from within 50 kilometres and manufactured in that same geographical area. So these things are possible. When we talk about tall timber buildings, we also talk about autarkic city districts, and that might be a word you're unfamiliar with, but basically means that in these buildings, how do they produce not only enough energy within themselves for the building to function, but how to create a surplus of energy to export into the grid or into other parts of the community buildings around. So there's a lot of really interesting research, development, and practice going on around the world, in America, in Australia, in New Zealand, in France. The regulations are changed to say every public building has to be at least 50% bio-based materials, which means predominantly wood. The Paris Olympics next year, all the temporary buildings have to be timber so they can be reused and repurposed elsewhere. Netherlands, I think there's something like 20 local authorities around Amsterdam have said everything timber has to be prioritized in construction. And that's true around the world. Even in New York, there's now legislation allowing for 6-story buildings in mass timber. Now, and that's a city which has been very, very resistant to any kind of timber construction. So things are changing. And as I say, lots of designs, I've seen designs and talked with architects and engineers about buildings that are planning up to 35 stories. At the moment, probably 20 stories seems to be the kind of the main kind of level of operation, and that's completely timber. So at Skidmore, Owings and Merrill, or SOM in Chicago a few years ago, did a fantastic research project as a multidisciplinary practice to say, could we build one of the buildings we did in the 1960s in steel and glass in timber? And they did the research and said, yes, we could reconstruct this 46-story building completely in timber, but we'd have to make all the connections in concrete because it's such a windy city. We have to weigh the building down. So that's the kind of research that's been going on. When we talk about the buildings or the designs I showed you, they're very much orthogonal, rectangular kind of plans and so on, but lots of ideas, lots of thinking going on about moving beyond that, looking at different kinds of shapes and forms, because the technology of manufacture of timber products now allows for incredible kind of opportunities for shaping and forming the products themselves. As I showed you earlier with this particular project in Seville. And you can see in the distance on the right-hand side, the cathedral. The cathedral is the largest Gothic cathedral in Spain. This building covers several more blocks than the Gothic cathedral. It's meant to cover a market. It was originally called the Parasol because it covers the marketplace and shields it from the hot sun in Andalusia. I think locally it's referred to as las setas, the mushrooms, but you can see, you can walk across the rooftops and so on. It's a new type of building form that didn't really exist that way before. And that's what I mean about what the technology offers now. In America, some years ago, when President Obama was in post, there was a competition introduced to say we want to stimulate mass timber buildings, particularly for tall timber buildings in the UK, and stimulate the forestry sector and manufacturing sector. And so they ran a competition. $1 million was the prize for a tall timber building. In the end, the judges said, we can't choose between two different projects. Obama said, give them both $1 million. So one was predicated for Portland and Oregon and one for New York. Neither of those buildings have been built yet, but what they have done is stimulate a rash of tall timber buildings all across America, with state after state changing their legislation to stimulate more use of timber, particularly mass timber. And you can see in this bill that was introduced in the Senate, it was introduced at the time of when Obama was in post. When it became President Trump, it kind of disappeared, and then but actually it's kind of passed through now as a Timber Innovation Act, because it was, well, I won't say hidden within an agricultural bill, but certainly it wasn't put up front in the same way. And so it was signed off by President Trump, because obviously he didn't read it. And so they have a bill for a Timber Innovation Act, which provides funds for education, for research, for prototype buildings, for demonstration projects, and for stimulus incentives for tall timber buildings. So it's about having the capacity as a profession, as an industry, to lobby for legislation that encourages certain things to happen that are responsive to the climate emergency we're living in. Can we use UK grown timber? Yes, we can. I'm going to be very quick here. I was involved for a long time at Edinburgh University in research and development on this. We used 6 different species. We made lots of panels. We took them to Timber Expo. Everybody said, this is fantastic. Can we get UK grown timber panels? And at that time, I thought, yes. And this goes back to about 2012. But our problem was that in Europe, you have the forest, the sawmill, and the sawmill investing in the manufacturing plant. So they're cheap by jowl. Here, the sawmills, the large sawmills, are not used to long-term investment, large-scale investment, and so there's, I won't say resistance, but it's just not happened so far, and the obvious investors really haven't picked up the baton, as it were. But there's a lot of research still going on with my former colleagues at Edinburgh University at the Built Environment and Smarter Transformation Centre. And we've been making things because we have a lot of forestry. It's nothing like Europe. When you see the statistics here of the amount of land cover of forestry in different countries in Central Europe, even in Spain, it's 35%. Here, England is mostly recreational forestry, hardwoods, deciduous trees. In Scotland, most of it's production forestry. Wales is a bit of a mixture, but we know we've got enough production forestry in my part of the world here to actually run a kind of large-scale manufacturing facility for many years to be commercially viable. And we've done enormous amounts of testing on everything you can think about to do with CLT, glulam, Dow lamination. We haven't done it on LVL because we have no machines to make the veneers here, but I recently discovered that we could use our Sitka spruce to actually do that, because there's been a lot of talk about producing prefabricated panels for the shafts for wind turbines, onshore wind turbines. That's another talk in itself. But the first installation we did of homegrown CLT panels is, as I said, about 12 years ago, 11 or 12 years ago, in this little visitor centre. We made shear walls for it, and that was really to get the show on the road. Then we sent a lot of timber to Derrick's, a company in Germany, to manufacture large-scale panels, and these were installed as party walls and shear walls in Athletes' Housing in the Commonwealth Games in Glasgow in 2014. So there was a lot of activity, and then it's kind of, I won't say stalled, because we've been now making at that best facility near Glasgow CLT panels, glulam panels, nail laminated panels. Oops, that's a bit of video. I don't have time for that just now. And we made systems for display at COP26 in November. It took a couple of years ago, and so there was housing modules, but also prototypical classrooms, which are now being taken up by the Department of Education in England, looking at how do we get these into kind of more general manufacture. And then here, still relatively small scale, but producing modular systems. A company called Ecosystems Technologies producing these, and these were teaching modules for a school in Edinburgh. You can see that rather kind of French chateau-style school. But these are fair-faced inside, glulam floor, so the glulam runs crosswise, so it bakes up a panel that's pretty much like I showed the way nail lamination would work, but as a glued system, and a series of panels put together. And then the ceiling here is kind of stepped sections of wood, so you get a kind of acoustic benefit. But more importantly, we've used wooden nails here. We've used basically beech dowels that have been densified and impregnated with phenolic resin, so that when you fire them in pneumatically, it stimulates the lignin in the softwood. And basically, that kind of has a kind of gluing effect. I have a whole series of panels, test panels of this, because we're making now, or testing cross-laminated panels made with wooden nails. And we're going to put them into a building on the west coast of Scotland shortly, inside an old ruin, so to create a new building inside the ruined walls, so to repurpose the facility for a new purpose. There's tons of information out there. A lot of this is downloadable, and we have it on our website at mastermore.academy.com. And so if you join the Mastermore Academy, you can get access to these, or save yourself looking for them all one by one, because we've done all the looking and hunting for all sorts of documents. We have many more than this available. There are other books you can buy and find out where some of the things are. We've had talks by, for example, the RIBA publication there, which is tied to the RIBA plan of work, to take you through the whole process of how to get CLT into the building. Nick Crawley, the author of that, works with DRM, not DRM, I'll come back to me. It's a fantastic book. The other books here, Trada's book, Solid Wood, covers a range of things, and plus some other mass timber systems they use in North America, like jumbo plywood, so on. Tall wood buildings, there's a lot more information coming out in that. So for us, with the Mastermore Academy, what's it all about? Why should you become a member? Because the whole point of what we do, and it's particularly, we call it continuing professional education, not development, because education is the bit that's missing. It's been missing in all our schools of architecture and engineering departments. We need to get the information out there, but it needs to be independent, objective information. Over many years, I've despaired at a lot of CPD I've seen, which is companies trying to kind of sell your product for an hour at lunchtime. We don't sell products. We don't recommend products. We give you the information, and a list of what the choices are, where you can go and make your own decisions. But what we're trying to do is build capacity in the industry to get you all au fait with all of these things, so that we can develop specialist expertise in timber design and construction. And we have 5 steps for that. We've been doing a lot of work with students at colleges and universities. We're really keen to get early career professionals involved, people within maybe 5 years of qualifying, and then professionals themselves and small practices and micro practices. When we've got through all of that, now really what we're trying to do is say, let's get understand, inspire you in the first instance, then say, okay, what do you need to know? How can we help you through a project if it's your first project? How can we help you get to the point where you become more confident about these things? Because with confidence comes creativity. You can't be creative with mass timber right at the beginning, because you need to understand much more about the properties of different species, different timbers, different technologies. But once you get to that point, we have a level of our courses, which is we call it timber entrepreneurs, which is really people with expertise through training in large offices who can then pass the knowledge on to other people in the office. Because our whole raison d'etre is to build capacity, to see how do we get maximum number of people in architectural technology and engineering really involved in understanding the way forward. A lot of the way forward can be with the kind of timber products we can manufacture nowadays. So we'd encourage you to become members. It's very cheap for students, for early career professionals. You'll get lots of bonuses and discounts and other courses, large discounts and other courses that we do. We've got courses coming up in the autumn and winter and spring. Mass timber, because that's a lot of the questions we get. Long span structures, hardwoods, mass timber, modified timber, another thing, and a whole series of masterclasses that are really to do with talking with architects or engineers who have done maybe 10 or 12 really interesting timber projects over the years, to look at the way their own philosophy and understanding as a practice of timber has developed, because they're not all designing identical buildings. So we want to know more about not just the technology, but how they've interpreted the technology, how they've applied it, and what the lessons learned have been. So these are kind of masterclasses and case studies, and we'll be running a whole series of these from the autumn onwards, from really fantastic practices and consultancies. So a lot to think about. Yes, coming in the autumn, tall timber buildings, and we would really encourage you to become members. It's not expensive, but it is knowledge and education you're not going to get with the occasional thing. What we try to provide is sequential information. So every time you take a step with us, it builds your knowledge and builds your awareness. We want to make you well, 2 things. One is to make you the expert in your office so that you become more employable and possibly better paid, but also increase job mobility, because change is all about around us, and people are not necessarily staying in the same job for their whole career. They're looking for where the opportunity is to apply their skills in the best way. We want to give you that knowledge and skills. So that's the end of the, I won't call it a sales pitch, but just trying to encourage you to say there's a lot to learn about mass timber, and we're doing our best to provide that. And I hope we can encourage you to get involved with us. So thank you very much for that. I'm delighted to be able to answer questions as well. I think I've kept more or less the time. If I've not, then I'll get my wrist slapped no doubt later. But on that merry note, I shall come out of this, I think, and find out from this man.
No worries, Peter. Well, we've got a few questions, so what I'll do is I'll pitch them to you, and
I presume, can people actually see me, because I can't see myself here?
I could see you.
All right, okay, that's fantastic, because I can't see. Which
so
is the first for a mirror, you know, but
yeah. So first question is from Chris. How is fire resistance, such as 30/60 minutes, achieved when exposed structural timber elements are used in habitable spaces?
Okay, well, that's obviously relating to the thing that's bandied around called the char layer. And the thing about timber in different species is when a room's ignited, if you like, an interior, you'll have a surface spread of flame, first of all, and that's the first thing to think about, how to address that or to prevent that. If the room combusts, if you reach this flash over and the whole place goes up, then the outer layer of the timber will char. It will burn and it will char through to a calculatable depth, because we know how much depth to calculate on different species to achieve 30 minutes resistance, to achieve 60 minutes resistance, or 90 minutes resistance. Now, and so what happens when you calculate as an engineer the section of a beam or a panel is you'll calculate the structural strength and stiffness of that, and then add on that dimension as the char layer, so that if that burns to that point, the actual structural resilience or integrity, I should say, of the panel or the beam will still be there. So I can show you all sorts of slides of what happens in the same temperature of fire to steel, which just melts and deforms all over the place, and what happens with timber, which tends to be still standing. And that also ties into a lot of work that's going on about seismic testing for tall timber buildings, because we know that we have much more elasticity in the structure than concrete frames or steel frames, and so they tend not to collapse. But also, I don't want to go on about this, but for an awful lot of things we've seen recently of earthquakes and things, what you see is a level of corruption in the industry, in the wider global industry, of leaving out reinforcing bars or poor concrete mixes. The recent things in Turkey and Syria were just shocking, the way the buildings just pancaked. That, broadly speaking, would not tend to happen with the timber structure properly designed. And a lot of that is to do with tall timber buildings having kind of honeycomb plans of panels, not being progressive, not allowing for progressive collapse and so on. But that's another discussion. The fire thing is being addressed in a lot of different ways, in a lot of a huge amount of research going on in different parts of the world, particularly in North America, and so amazing kind of level of investment in fire testing. We have a little problem here because we don't have enough or sufficient facilities to do fire testing in this country. I was recently involved with a practice in London who were doing a project in South London for a big, one of the biggest developers, and the local fire officers wanted full-scale fire tests, which were not possible in this country. Then they had to do them in Nice. Now, this is just colossally expensive, but it tends to be the similar results come out of these tests and all the time. So we need to get a bit cleverer about it, but as I say, a huge amount of work's going on at the moment with collaboration between insurers, mortgage providers, developers, architects, engineers, to create a new level of information. And TD UK, Timber Development UK, used to be TRADA and so on. They recently produced a little publication, which I think was developed by Watherson Architects, to show a lot of the ways of designing to address these questions. So hopefully I can point you to all of these kind of documents and things, and I can send you the links to download them or whatever. But it's a much bigger subject I can answer at the moment about the chart.
Okay, so I'm gonna. We've probably got time for probably two more questions. So I'm going to ask a question regarding the glues. So what glues are currently being used? Is there any off-gassing, environmental properties, etc., and so on?
Sure. In a separate presentation, I have a whole slide about all the different glues that have been used in the development of mass timber technologies. Now, they really come down to most of the formaldehyde-based, all of the formaldehyde-based glues have been kind of outlawed by the European Union. And so now we have the one that's used most is a PUR glue, a polyurethane glue, because there's very little off-gassing. If there's anything in that respect, it happens in the curing of the glue, not beyond. And so any testing that's been done about that shows practically no emissions. So I'm not trying to flannel you about this. I think, again, a lot of research is going into this, and constant research to see how we can make sure the adhesives involved in mass timber manufacture are effective and work in, because one of the other things here when we talked about fire was about discussions about if you burn through the outer lamella, whether then the glue can ignite and start off the next level. I think a lot of research is going into the glues to say that's not the case, or shouldn't be the case, or won't be the case. So a lot of things in that respect going on. So the glues, I can tell you a lot more about that in a separate session, or if you join one of our courses about this, we can give you chapter and verse and all of this.
Great. And then I'm just trying to find a final question. There was lots of questions. So on that, I know Peter would be more than happy to communicate directly. So please do get in touch with the Mass Timber Academy. As he's mentioned as well, is that they run a number of courses. Our regions in Scotland arranged for a mini series which I attended, which was extremely interesting. So I do encourage you to keep an eye and see if there's anything that you'd like to partake in. There is a Q&A, detailed Q&A session which Peter takes part in towards the end, and also as well takes questions away to answer at subsequent events as well. So it's an ever-evolving space, and there's a number of books and publications on the matter. It's a very interesting subject, to say the least. So I'm just trying to find a suitable question to close it off. Just give me a second.
It's okay. I know you're hunting for an easy one.
Yeah, I'm trying a nice one to sort of clean us out, basically.
While Usman's looking for a question, I'll just say, hopefully I can get a list of the questions that have come up that I've not been able to answer today, and I can provide a kind of pro forma list back to Usman and CIAT Wessex for distribution to all the people that have signed up today, so they can see what kind of questions other people were asking and what kind of answers we've been able to deliver.
Here's an interesting one from Xavier. It was mentioned that DLT is used less now than CLT timber. Wouldn't DLT offer benefits in terms of minimizing the use of potential harmful adhesives along with the deconstruction and reuse of individual panels? And generally, sort of to take that further, he's mentioned in there as well, but just to sort of fill it out a little bit more about the whole life cycle span of reuse and sort of alternative uses and so on. That'd be interesting to hear, sort of as a final question to close us off.
Okay, I'll be very quick. We've been doing a lot of work on this over the last few years of looking at how do we develop genuinely affordable housing in rural parts of the country. And in Scotland, for example, we have a lot of communities who manage community land buyouts. And so they have land, and they have land with forestry on it. And what we've been trying to do is develop a system where they can manufacture their own panels, relatively small panels, maybe 1.2 meter wide, so they can build a wall in sections and floors in sections and so on, but give them the opportunities to upskill the community and create jobs as well as housing, but use their own resources because they own the land, they own the forest, use their own resources to build genuinely affordable housing. Now we've been doing that. We started off looking at that from dowel lamination, and we were looking to develop a machine to make a mobile machine that we could take to different remote areas, something that could go up single track roads. And we've moved on from that, so we're really working quite hard on nail lamination now, because with nail lamination, in order that, exactly as the question, we can take panels apart later. We can also make the manufacturing process relatively simple for people. So it's not a high skill thing, but we can produce sizable thick panels which also have higher thermal capacity. So we're doing a lot of work on this at the moment, and looking to see a few buildings in the next little while made this way. I firmly believe, having spent many years trying to see CLT into manufacture in the UK, that we're still many years away from that. Partly because now it's so, the technology is advancing and the demand around the world is such. Most of the machines to do this are made in Central Europe, and they're running at full capacity. So you know that even if we made a decision today to build a CLT factory, for example, it might be 4 or 5 years away before it was actually into use, before we could get the machines. So a lot of what I've been interested in the last little while is saying, how do we do things more locally around Britain? How do we do it where we can create local employment and not look for a massive market that's required for a big commercial factory who needs lots of security of future orders and things to justify the investment, because the investment in these factories now in Europe is between 20 and 60 million euros. So it's big bucks, and seeing a return on that quickly is not really what's possible here. Here we don't see that kind of longer term investment as a possibility. We look for fast returns on investment. So, and my own view now is if we can do a lot more locally, because and a lot of it can be domestic scale with dowel lamination or wood nail lamination, then we can achieve a lot more and answer a lot more questions about the affordability of buildings.
Great, thank you so much, Peter. So I just want to wrap it up by thanking Peter very much for speaking about an extremely detailed subject which requires a number of courses to actually sort of get to grips with. And as he mentioned, the Mass Timber Academy is a great resource for you to guys to have a look at. So please do take a look if that's something you want to if you have a project or if you're considering projects in this area. So that was today's event. So the Mass Timber Technology Revolution in Construction. Our next event is on the 13th of September, which is another one with our CPD in 43 series, is How We Let Grenfell Happen, which is from Peter Apps regarding the Grenfell tragedy. He's an award-winning author and followed this very closely throughout. It's an award-winning book. I do recommend you reading through it as it's an essential piece
It's a
of...
jaw-dropping book.
Yeah, it's a very just be ready if you do read it, just be ready to yeah, it's a very jaw-dropping book. But is something that we should all get to grips with. This is obviously one of the big sort of changes that are coming into the built environment, is a building safety bill, which we will also look to have talks on in the new year. But this one is from the author, so please do register and attend. That is live on Eventbrite. The following one, this one is from a UK government security advisor, protecting the physical and digital engineered world. This will be a live only event. This will not be recorded. This will not be posted to YouTube. Very interesting event. I've been to a number of his CPDs. Really interesting, really different understanding of the way in which the built environment needs to be developed and how you need to secure your data as well. So lots of really interesting information there. That's on Wednesday, the 11th of October. That should either be live or will be going live on Eventbrite soon and will be advertised on all the relevant channels. The event in November, on the 15th of November, is Inclusive Design, Common and Less Well-Known Issues. Again, this is from a leading figure in the inclusive design arena, and he is also a published author. So really interesting event, so please do attend that. And then the final one for the year, which will be on Wednesday the 6th of December, is Technical Considerations When Designing with Brick, from Weinerberger. This again will not be a recorded event due to this being a course that they hold on a regular basis. Therefore, this is an attend-only event, so please do sign up for all of these as they're released. They will be advertised via central office on the Wessex Committee's social media, so please do follow and like those media channels for any updates. Please do contact me directly if you have any ideas about future CPDs. We're currently working on the 2024 schedule of events, and generally we're always open for feedback, and thank you for everyone attending. I think we went well over 200 people attending today, so it's great to see you all and look forward to seeing you guys next month. Thank you so much.
And thank you for inviting me.
Thank you, Peter.